pointer, no? Thanks, Jonathan. The Ice Bucket Challenge, actually, I think those figures were very interesting. And I remember walking through around the shops in Dundrum with my daughter, who's now 24, who was 14 at the time. And we're just chatting. I said, you know, I'm doing that thing, you know, with the bucket, you know, the ice thing. I said, oh, really, you're going to do that? She said, yeah, we're going to do it in the school. And I said, you know what it's for? And she said, oh, some, you know, men. I said, it's for MND. I said, oh, right. I said, you know, that's what I do. I said, oh, really? So that's how extensive the knowledge was about the ice bucket, that even 14-year-olds who completely disinterested in their parents' lives actually it had got to them. I could say things about Peter as well, but I'm a very polite person, so I'm not going to. Well, I won't. Anybody wants to know about Peter later, you can come to me. So I'm going to talk about, I was asked to talk about genetics, so I am going to talk about genetics as well, but I asked Tracy, would it be okay to talk about something that is really important from my point of view, and I think from everybody's point of view, which is what we're trying to do to move the field forward in terms of why we don't have any treatments. Why aren't there any treatments? It's a really obvious question. We can cure the disease in mice, we can cure the disease in worms, we can cure the disease in flies, but we haven't been able to make that translation into people. So why don't we have any effective treatments? And it's been something that has really challenged us throughout our careers, myself and Peter and all the people who work with us in the delivery of care, not just in Ireland, but across the world, and that's what the Ice Bucket was about as well. And so I want to talk a little bit about what we're doing, and a lot of people in the room are helping us to do this, to try and understand why we don't have effective treatments and where we should be going to make this a world where we have the right drug for the right person at the right time and the right dose. So part of the problem is that we talk about MND, the other name for MND is ALS. So MND, it's called MND in the UK and here, but everywhere else in the world it's called ALS. So we use the terms interchangeably. But the point is that everybody's condition is different, and almost certainly, well, not almost certainly, certainly it's more than one condition. So clinically, when we see people in the clinic like we did yesterday, we can say, we think you have motor neuron disease, but we always say, but the experience or the strain or the type of motor neuron disease that you have is almost certainly different from the type or strain or subtype of motor neuron disease that your neighbour that you knew, or that Charlie Bird had, or that other people that we know, or Colin Murray or Tony Coote, all the people over the years who have helped to make, to publicise this condition and have helped us to raise funds. So we know that it's more than one condition. We know that the way the condition progresses is different for different people. And we always say that to people, it's an individual journey, and we'll walk the walk with you, and we can try and anticipate what's going to happen. But from a scientific and biological point of view, it's different as well. And that's the big challenge, to understand what those differences are, what they mean, and what they mean in terms of trying to get new treatments. And one of the things that has been difficult from our point of view, both nationally and internationally, is that it's a relatively rare disease. It's not surprising that 1 in 5 people knows somebody or knows of somebody with motor neuron disease, because the incidence of motor neuron disease is almost the same as the incidence of multiple sclerosis, and everybody knows somebody who might have been affected by MS. So the lifetime risk of developing motor neuron disease is actually 1 in 300, 1 in 400 for women, and 1 in 350 for men. So it's about 1 in 375. So now obviously our lifetime risk of getting cancer is 1 in 3, or having a stroke is 1 in 3. So compared to those really common diseases, it's relatively rare, and it's classified as a rare disease. But it's not that uncommon. So it's not unusual that somebody might know somebody with motor neuron disease. But it's still relatively rare in terms of being able to understand the biology of that variability of the disease. and trying to pick out those smaller groups of people that share common features of the disease, that we could then try to understand what those features are and how we might treat those. So I'm working with my colleagues across Europe, and we just included 4 more centres into the TRICALS group, the Treatment Initiative for ALS. So we have I think it's 62 centres around Europe now. I'm the co-chair of this group, and our collective objective is to find new treatments that work for motor neuron disease, and to work with ourselves, to work collectively as research teams, but also to work collaboratively with industry partners to try and find better treatments for this disease, and to understand the mistakes that we made over the years for why we didn't find, over the 100 trials that we've done, why we didn't find a drug that really works, except for riluzole, which does work, but not as effective as we'd like it to be. So we worked out a few years ago, if we think about this as a roadmap or a highway to better treatments, what do we need to do to make this, to understand the disease? And part of what we need to do is to work collaboratively or collectively, because no one country has enough people with the different subtypes of motor neuron disease to be able to really study this properly. So we have a register in Ireland, and I think everybody in this room has been asked, would it be okay to put your information on our database? And over the last 30 years, nobody has ever said no, actually. It's been fantastic. So we have information from about 2,500 people on our register over 30 years. And my colleagues across Europe similarly. But 2,500 people for a condition where there's lots of different subtypes isn't enough. So we need to work with our other colleagues across Europe to combine our what we would call our data sets, our information, to identify subgroups, and then to understand the different subtypes by looking at different blood markers, or I think Peter talked about the brainwave testing and the imaging markers that he's working on, they're called biomarkers, and then to work with our colleagues in industry to help to make the clinical trials a bit more fit for purpose, to have a new way of collecting the information so that we can do it in the longer term, and then to improve how we identify what's happening in the disease, because we're not very good at that at the moment either. So the whole purpose is to use a sort of catchphrase now that is called precision medicine. So I was at a series of talks I was telling Peter during the coffee over in the Clinical Research Centre in St. James's, where we do our early phase gene therapy studies. And all of the speakers, the St. James is a big cancer centre as well. And I have personal family experience of engaging in that centre from a cancer point of view. And cancer has really moved forward in terms of precision medicine. So there are lots of new treatments now for cancer, and they're all targeted at subgroups of people with cancer. So it's a little bit easy to do that, because you can take the cancer tissue out, look at it, look at the difference in the cells and the cancer, and then start new treatments. But it was really uplifting and exciting to see where the cancer field has gone and where we might go in the neurodegenerative disease as well, with this concept of precision medicine. Precision medicine is tailoring the medical treatment to the individual characteristics of the person. So to be able to classify people into subpopulations and their susceptibilities and the type of disease that they have, and then to move that forward. That's what we're trying to do. So our mission in TRICALS, like I said, is to help to find the right drug for the right person in the right dose at the right time. That's our motto in TRICALS. So in order to do that, we have to, the roadmap that we've generated is where we want to go. So we've been lucky because Science Foundation Ireland, which is a big scientific funding body, they're called Taide Éireann now, or Research Ireland, they've just changed their name, but they have this program, these programs where they fund big research centres, and I'm a member of 2 of those big research centres, one in Trinity in a big data science, computational, artificial intelligence centre called ADAPT, and then the other one, which is the centre which is called Resurgence, which is called Future Neuro. And so we, because I'm a member of both, I said to both, can we put in a proposal from these 2 centres to try and build a precision medicine program for motor neuron disease for ALS. So we put in a grant to Science Foundation Ireland. It's an academic industry proposal, so we have some industry partners as well, some of the companies that are interested in developing new drugs. And it's a collaboration that I lead, but it's with all our 16 centres in Europe now to try and fix this problem of data so that we can subtype the disease at scale using machine learning and artificial intelligence. So we've asked most people here, either have been asked or will be asked, would they participate in the Precision ALS program? And the idea here is to identify everything we can about the person, and that is mostly asking questions and taking some blood samples, and sometimes doing the brainwave testing, and sometimes doing the imaging that Peter does, and then put all of that on a big platform that we've built in ADAPT, and then put in our data scientists and our computational scientists and our machine learning and our artificial intelligence people, so that they can start looking at the data and trying to identify patterns that I wouldn't be able to, or Peter wouldn't be able to see because we're clinicians, so that everybody in this room will have or there'll be little groups of people in this room with different characteristics that they hold in common, that then we could start investigating and say, okay, so you have this subtype, so this type of drug is more likely to be beneficial at this stage of your disease, or this type of drug might be more beneficial in this subgroup, or you have a different stage of disease. So that's what we're trying to do. So, so Precision ALS has a machine learning, multimodal data, that means lots of different types of data, and then a machine learning component, and the outputs are so that we can segregate people into different subtypes that are appropriate, and then provide those subtypes for both analysis, but also to bring more precision-based clinical trials into the program. So the purpose of Precision ALS, or the objectives, are to, for people like me and Peter who are clinicians, and people who are in the room here, to work together. So we ask you for information, a bit more information. We use the stuff that's in the chart. We take blood samples. We do a few other things as well, and we integrate that then. And with our data scientists, they build our platform, and it's in the middle being built at the moment. And then out of that, we generate new knowledge that'll drive the field forward. We're about halfway through the project at the moment, and these are the sites that are participating in Precision ALS, but we're leading it. So it's a really exciting project. It's eating up most of my time at the moment, actually. And it's most of the time I was talking to lawyers, actually, because there's a lot of legal framework involved in this as well. But it's moving now, and we've collected about 900 people so far. Our aim is to collect about 1,500 per year. But we've also been able to harness the information that we already have, so our register plus the registers around Europe. So we have on our platform information from about almost 24,000 people across Europe who've had motor neuron disease or have motor neuron disease. And there are a bit of some holes in the data because it wasn't collected specifically for this purpose. But we've already been able to start doing some artificial intelligence, machine learning on this, and we have a group which is led out of Trinity, but groups around Europe who are working this, and some of our people here, some of you might have met Rob McFarlane. Rob is one of our research registrars, a really good doctor, but a really clever, talented young man as well. And he just got a big grant from a big funding agency in the US called Target ALS to start doing some deep learning and machine learning with some of the data that we have and the data going forward. But we're also collecting information as we see people in the clinic. We ask people would they be willing to participate, and we're looking at what we call the patient journey. So every time somebody has any kind of clinical encounter, we're asking people to give us information about that clinical encounter, either by allowing us to look at their chart, or by giving them a phone call and ask them, or by asking them to participate in some of the remote monitoring studies that we're going to talk about in a minute, and we ask people for blood samples as well. And we're looking at other things like quality of life. We are interested in carer burden. the caregiver is really important, and that's a strand that we're building. IMNDA had been providing some funding to support that programme through Miriam Galvin, so I'll be talking to Mr. Burns afterwards about that. Just put you on notice there to continue that project. So we ask people for their consent about the project, and if somebody consents, we ask them for information about their health, collected after every clinic visit and sometimes after visits from the community. We ask them about services they use. We ask for a blood sample, and we ask for their DNA, and we ask them, is it okay if we analyse their DNA? And the information then is coded. Your name and address isn't on, so nobody could get into our platform and figure out who you are. And our collaborating centres across Europe cooperate then to find these patterns of disease. That's the idea behind it, to try and find new treatments. So we're aiming to enrol about 75% of every new diagnosis across Europe, including here, and about 25% of people who were diagnosed before the project started. So we're aiming for about 1,500 new people per year over the next over the next 2 years. So about 45,000, 4,500 over 3 years. And so by the end of 2026 or the early 27, we're hoping to have almost 30,000. So that'll be enough. That'll be a nice, large number into which we can start doing some of the studies that we are doing and open up new questions. So some of the things we're looking at are things called biomarkers of the disease. So this is understanding the subtypes of disease, understanding whether the disease is going to move fast or going to move slow, understanding the biological factors underneath the disease, using markers to determine whether the drug is working or not. And sometimes markers are genetic as well, to try and see if a particular subtype of disease would respond to a particular treatment. So biomarkers are around blood, and in some centres they take spinal fluid. We don't do that in Ireland. They're the stuff that Peter is doing, and they're some of the electrical activity, brainwave testing, and we're also looking at muscle testing as well. One of our researchers, Lara Glanis, is looking at muscle testing as well. So it's a big project. Not every centre is doing everything, but we're going to add all the data together. We're also looking at, and I think we've had some discussion with people, and Leslie and Megan are in the audience here. You, there they are, over there. Yep. And Avril, sorry, are in the audience here, and this is looking at remote monitoring. So we've got a project just starting that is being run by our colleagues who are part of a grant funded by the Health Research Board, looking at monitoring, how good are the monitoring devices that we use, so that we can obtain more information, but at low burden. So Leslie gave me a couple of slides on this. So precisely measuring changes in physical function using these different technologies: activity, breathing, walking, hand movements, speech, swallowing, and there are some questionnaires. Are you going to talk about that, Leslie, after? It's okay, so I'm talking. She's here. Stand up, shout to us, two of you. Some of you might know Deirdre. She's in our clinic, but she's also an academic, Deirdre Murray, and Dara Meldrum, who's a very successful physiotherapist entrepreneur. And then the research team in this are Leslie, David, Emily, and another David. So is Emily here? No? Okay, so Leslie's representing this. So Leslie's going to launch this study. If you're interested in the study, here's the email for that as well. Is there anything you want to say about that, Leslie? No? Okay. About Debbie, sorry, I'm deaf. She said they're all outside afterwards, so yeah. So she'd be delighted to talk to you. So it's going to launch in this month, but it's a really important study. We're part of a big research group across Europe, which Deirdre's leading out on, with Utrecht, and there's a group in Canada and there's a group in Australia, but the centre of gravity of that is within Precision and Miranda, the study that Deirdre's involved. And then the data analytics and machine learning, that's what we're doing. This is what I was talking about, using artificial intelligence. Artificial intelligence is great if it has the right data. Artificial intelligence is rubbish if you don't have enough data. Well, we did some work a few years ago with somebody does machine learning in UCD, and we used some of the data that we had generated, that Miriam had generated, Miriam Galvin, we're interested in caregiver burden. But the data that we were using wasn't as complete as we would have liked. And what the machine learning showed was that caregiver burden is increased if the person can use a fork. I mean so rubbish in, rubbish out. So the machine learning and artificial intelligence is only as good as the data sets that we have. So the data that we're generating has to be really high quality. So we're investing a huge amount of money into that so that we can have the outputs afterwards. So these are the companies that are involved, and these are the centres that are participating in precision. So the last part of my talk is I've a different colour to say it's actually a slightly different set of things that Tracy asked me to talk about that I think are really important to talk about. And it's an update on genes, gene testing. And so what do we know about this? Where are we at it, and where should we be going forward? So motor neuron disease is a disease where there's a big genetic component. So about 5% of people who have motor neuron disease have a first-degree relative, have somebody else who's either a sibling or a child or a parent with motor neuron disease. If you extend it out a little bit, that goes up to about 16% if you're talking about uncles and aunts or nieces or nephews. And if you extend it out a little bit more to other conditions that we know are linked to motor neuron disease, about 30%. Now, there are 4 big genes that are associated with motor neuron disease, and the rest of those genes are important to understand the biology of the disease, but they're not really important in the day-to-day management of the disease. But it's important to know that, so these are the 4 genes. CNNOF, SOD1 is first described, TDP43, FUS, and CNNOF72. I have a taxon 2 circle there because there was a clinical trial for a taxon 2 as well. We didn't participate in that, but the trial was negative. So if we know that there are certain genes that are linked to motor neuron disease, there was a lot of debate over the last few years about should we be testing? It's expensive. It's become cheaper now than it used to be. So there are lots of companies around now who will do gene testing for us, or they're called gene panels. So they will, if we say this person has motor neuron disease, we can send a blood sample. We send it to Germany, and they test all the genes that we know are associated with motor neuron disease, and send us back the results. And then it used to be the case that we only tested people who had somebody else in the family with motor neuron disease. But we and many others have shown that actually this is not true, that there is some variability. Even if there's nobody in the family, it's still worthwhile testing, because you do pick up, in about 30% of people you might find something. This is a European study, it's a little bit less in Ireland, but it's worthwhile testing. So we offer genetic testing to everybody now who comes to our clinic. So anybody who's come to our clinic will say, would you like us to test you for the known genes? I suspect you aren't going to have any, because we kind of know the patterns now. And the majority of people have said, yes, I would like to know. And then it takes about 6 weeks now or to get the results back, and we'll tell people when they come back to it. It used to take us longer. We used to go to Sheffield in the UK to send the samples. They were very slow. So we've moved to a company called CGAT in Germany now, and they're pretty good, about 6 weeks to 2 months. So which genes should we test? Well, this is just looking at this across Europe. This is Rob's work, actually, Rob McFarlane. So the 4 big genes in Europe are these I mentioned: CNNOF72, FUS, SOD1, and TDP43. And you can see in Ireland that of those 4 genes, we have very, very few of the other 3. The only one that we really see in Ireland is CNNOF72. It's about 11% of people with motor neuron disease in Ireland have this gene. And it is important to know, because FUS, we're doing a clinical trial. SOD1, there's a treatment, and CNNOF, there will be clinical trials. So it's important. We don't have trials yet for TDP43, but we don't have anybody. I think we had 2 people in there for Northern Ireland who had variants in TDP43. So I was talking briefly about the treatment for SOD1-related disease. It's called Qalsody, and we've had a lot of people ask us about this. Could I go on Qalsody because it looks like it works? So it is a gene therapy, and it works, probably. It's just been licensed by EMA, the European Regulatory Authority. It targets people only who have the mutation in this gene. We don't see this mutation in Ireland. We've 1 person at the moment, I don't think he's here actually, who carries this gene, but he's not Irish, he's from a different country. It doesn't work in people who don't carry the SOD1 mutation. But there are other gene therapy studies underway. So we did 2 studies on C9orf72, and neither of them worked, and there's lots of scientific reasons why I think that is the case, why that clinical trial didn't work. We're doing a FUS mutation, so we have a family in whom we know there's a FUS mutation, and 2 of those family members are on this trial. And there's another study that we're doing, very early studies. They don't happen in Beaumont. We do them over at St. James's because we have to inject the treatment into the spinal fluid. There are many other trials in the pipeline, but they're in early stages. So we're also looking for new genes. So we ask people in our clinic, would you like for us to check you with a gene panel? And then we ask you for another sample, and that goes into our DNA bank. And we've got a big, large-scale collaboration called Project Mine, which is looking at variants that might make you at slightly risk of motor neuron disease, but other things have to happen as well. And so Project Mine is linked with Precision ALS, and the idea would be that we'll combine all those little variants with Project Mine with what the big data set that we have from people in Precision ALS, and pull out people with different combinations of genes that might tell us something more about the way the disease is in a particular person. So we asked people, would they give us a blood sample? We sent it to Project Mine. So that's a picture of the award we won a couple of years ago called the Healy Foundation. We're the founders of Project Mine, so we're one of the founders as well. So then we get asked sometimes about, well, my mother or my father or my sibling has motor neuron disease. I don't have any symptoms. Should I be tested? And we were very reluctant to that. Sometimes we have families that look like this. That's clearly familial motor neuron disease, but actually the vast majority of people look a bit more like this. So there's somebody in the family, but sometimes they've passed away as well. And the question is, does somebody else in the family is worried, should they be tested? Or what are their risks if we know, for example, that the person has a C9orf72 mutation that's probably associated with their disease, and another family member wants to be tested and they carry the gene, what does that mean for them? And it used to be thought that gene was identified about 10 years ago. It's identified by Brian Traynor, actually, who did his early training with me. But we know now that you can carry that variant and not have anything. So only about, even if you carry the variant, only about 20% of people who carry the variant will get the disease. So that's a study there are 2 studies that came out recently, one from my colleagues in the Netherlands, and another from the UK showing the same thing. So if we go to test people, we have to explain to them that, so that's the 2 studies I talked about, that it's only really transmitted, the disease, in about a fifth of people who carry the variant. So if we're going to do testing and counseling, we have to really clear that we don't really know what the risks are. We know that you carry the variant, and some people may want to know, and some people may not. There may be some advantages in knowing if there are going to be new treatments down the line where we treat before the disease starts, but then we'd have to know if you're one of these people who's at higher risk of getting the disease or not, and we don't know that yet. So what we've done now is we've recognised the needs and the desires of family members, and we're just about to set up a specialist nurse-led clinic with our new AMP, Sinead Jordan, for family members. And we put in a proposal to the HSE last summer, 18 months ago, to fund our clinic, and all of the posts that we put in, we got funded for. So Annette is one of those, and our speech therapist, our occupational therapist, are all new people that we got in under this program, which is all funded. But we put in for genetic cancer, and we lost the genetic cancer because of the embargo, and then all the money disappeared. So we had no genetic cancer. So I was very reluctant to set up a clinic without actually proper support from genetic. But we have the loan of a genetic cancer now. A young man called Michael Novelli, who's South African but properly trained. So Michael is going to come and help us with this. And so we will provide genetic counselling now for people, family members, if they want to. So anybody who wants to participate in that, who wants to know whether they carry a gene or not, if there's a gene in the family. We have to know if the gene is in the family first. So we'd have to know if a relative carries a gene. We can't do it if there isn't a relative who carries a gene. We're hoping to start this in the end of this year, beginning of next year. It's going to happen in Omni. So it's not going to happen on the Beaumont campus. Beaumont has hired space up just a little bit, a mile or two up from Beaumont Hospital in the Omni Centre. So to conclude, there are multiple subtypes of motor neuron disease, and our clinical trials haven't been that successful for that reason, but there are many trials that are beginning to adopt this sort of precision medicine approach. And our precision ALS approach will really make a difference. And we've got a lot of international traction about this. I was in the US last year, I was in Canada this year, I was in Argentina, I was in Australia, talking about precision ALS. People internationally, there's a huge amount. I'm going to New York next week. There's an international interest in precision ALS because it's seen as the way forward. There's a couple of other initiatives around the world. The idea would be harmonize everything. So there's a group called All ALS in the US and other people doing that. So we're going to try and harmonize how we collect data. So we'll have massive data sets that we can start to do this. So, and then finally, genetic testing is offered to people who come to Beaumont. We have to consent you for that, but we expect to have clinics running for unaffected relatives who want to know with the genetic from families with the genetic forms, and we're hoping to have that. I think that's. I think it might be before 2025, but I'm hoping to have it at the end of this year. And there are some new trials on the horizon, and we're part of TriCal, so we meet every 2 weeks, our TriCal's executive, where we consult with industry, we advise industry. We have our big symposium in December where all the industries who are interested in motor neuron disease come to our symposium. It's in Montreal this year, and we'll be working through new trials with those as well. So when I go, which is in a couple of years' time, Peter will be going to all those meetings instead of me. So that's it. That's what I want to talk about. This is our group. We've got a big team. I didn't even put the precision ALS team here, but you probably met some of these people over the years. I'm happy to take questions later. Thanks very much.
Thank you, Orla.